Hello, welcome to Super Easy Physics and Mathematics. I'm Orisheje Matthew. In this video, we are going to look at the application of trig ratio to solve practical engineering problem. So like in this question that we have here, a cable car climbs at 50 degrees to the horizontal and then is used to transport passengers up the hill. So it climbs up the mountainside and then the distance AB from the base of the cable car to this point given, when the cable car is just traveling up, is 55 meters. So this point here is 55 meters. That is AB. This distance from here to here is 55 meters. Okay, so let's get the additional information. And then ED is 38 meters from the base of the cable car just directly under it, then to the base of the cable car, that when we measure the perpendicular height down from the top, the base of the cable car at the top of the mountain down to the base here. So let's look at the questions. Calculate the total length of the cable car AC. What is the total length of the cable car from the bottom of the mountain to the top of the mountain? That is one. Then secondly, calculate the vertical height gain from A to C. If the cable car travel from the base of the mountain to the top of the mountain, what will be the vertical height gain? What is the perpendicular height? So this is the question we are going to be looking at in this video. So we are going to apply trigonometry ratio to solve the problem. So what we need to do, we can just have a small sketch of what we are going to solve here. So you have this trigonometry ratio. So then at this point here, 50 degrees, then from here to here is 55 meters. And then we have this point A, we have this point B, we have here C, then here is E, and then here is D. So we are expected to find the first distance we are looking for is from A to C. So that's the first thing. And then the second thing, we are going to look for this height here. Okay, so these are the two distances we are going to find in this particular video. So let's see, but let's just do a little bit of critical thinking. For us to apply trigonometry ratio, the information given to us, you can't get H directly because you don't know the hypotenuse, the total length of the hypotenuse. So the first thing, but we were given part of the distance here, which is 38 meters, and we are not given the full length of the adjacent. So we can't apply trigonometry ratio directly. And when we are applying trigonometry ratio, what is the simple way? We normally use this mnemonic, so, ka, toi. So if you look at that, then the SOHCAHTOA means sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and then tan theta is equal to opposite over adjacent. So we're going to look at that. So for us to be able to get that, since we know part of this, so let's find the full length of the adjacent. So let's calculate AD. And then AD is equal to AE plus ED. All right. So let's get this particular distance. So we know ED 38, but we don't know this one yet. So let's find AE. So for us to get AE, We'll now look at triangle ABE. So we say in triangle ABE, very good. In triangle ABE, we want to calculate the adjacent, which is adjacent over hypotenuse. So that is going to be cos. So we say cos 50 degree is equal to AE adjacent over hypotenuse over 55 meter. So this one simply means AE is equal to 55 multiply cos 50 degree. So you can get that. So 55 times, so we get the value which is cos 50, that is 0.6428, okay, in meter. So if you multiply this value, that is going to give us 35.354 meter. Okay, now we know this, so let's approximate it to the nearest value. So that is approximately 35.4. So to one decimal place, 35.4 meter. So that is the distance here. So the distance here is 35.4 meter. So add it together, we cannot get AD. Therefore, AD, which is a full length of the horizontal base of the cable car construction, is going to be AE, which is 35.4 meter, plus ED, which is 38 meter. So the full length of AD is equal to 73.4 meter. Okay, now that we know this length, I don't want to clean off this diagram, so I will take this off, but let me indicate the full length on the diagram. So we have this full length now on this diagram. So from here to here is 73.4 meter. So having known this, we cannot relate the angle of elevation of the cable car system to the horizontal. So if we relate the adjacent to the angle, we can get the hypotenuse AC and we can get the vertical height CD. So let's get the first part now. So what is the total length of the cable car? So wait. So let's get now we want to get the length of the cable car, which is the total length of the cable AC. So the total length of the cable is the hypotenuse related to the adjacent. So which one connects hypotenuse and adjacent? So which is this car? So we're going to say cos 50 degree is equal to the adjacent over hypotenuse. So it's going to be 73.4 meter over AC. Okay, so so let's make AC sort of formula. Therefore, AC is equal to 73.4 meter divided by cos 50 degree. And then cos 50 degree So this will become 73.4 meter divided by, so if you press cos 50 on your calculator, what you get, that is going to give you 0.6428. So 0.6428. So you can now divide that. If you divide that on your calculator, it's going to give you. So have you done the division? I want you to just press this on your calculator. Okay. Right, you got 114 point what? 188. 188 meter. So it's approximately the length of the cable, the distance that the passenger will travel through is 114.2 meter. So that is the total length of the cable car from the base to the top of the mountain. Okay. Now, we've gotten the A part of the question. So let's get the B part of the question, which is calculating the height vertically from the top of the mountain to the horizontal base here, a perpendicular line that connects the top to the horizontal line at the bottom. So let's look at that. So let's remove this part. All right, so let's look at the second part of the question, which is the vertical height gained by the cable car as it moves from position A to the top of the mountain C. So what is the vertical height gain? So the cable car is actually moving this way up right to the top of the mountain. So let's calculate the vertical height rise. If it were to be physics, we can now calculate the potential energy of the passenger at the top of the mountain. But we are not doing that, so let's leave that. So now, what we are going to look, we are connecting opposite to adjacent. So opposite of adjacent, that is going to be tan theta. So we say tan 50 degree is equal to CD over 73.4 meter. So what is CD? So CD, which is the height h, is equal to 73.4 times tan 50 degree. Okay, so this will become 73.4 times 1.732 tan 50 degree is 1.732. Very good. So if you multiply this, what is going to be the total answer? 127.12, yes, 88 meter. So that is approximately to one decimal point. That is going to be 127.2 meter. Awesome. So we've been able to solve this particular problem. All right, so the next thing you are going to do now, I'm going to give you a simple question that I'm going to do, but I'm going to give you a bridge that is constructed over a valley. So I want you to find the depth of the bridge. And so let me give you your comment work. Okay. All right, so this is the comment exercise. So I want you to find the full length of the bridge across the valley and then the depth of the valley that the bridge was constructed across. So see you, and I will see the first person that is going to solve this. Subscribe to Super Easy Physics and Mathematics. Our goal here is to help you improve in your understanding of mathematics and physics. Okay, I'm glad that you have gone through this video, And then we have more other questions that is coming. The next video I'm going to be producing is on physics, and I'll be talking about how metals expand. So just look out for that video. Thank you.